Hi, my name is Ernest Navarro, and I'm a BS IT student of AMA University Online Education. Today, we are going to do data communications and networking for course project. This activity will assess your knowledge and skills in applying one technologies and network services required by converged applications. Instructions: create a video representation, apply the basic knowledge, demonstrate the knowledge. So the topic that I choose is Group 1: point-to-point connections, branch connections, access control list. So let's go. Point-to-point connections. What is a point-to-point connection? A point-to-point connection is a permanent direct communication link between two parties. Unlike a dial-up connection, it does not need to be established via dial-up or disconnected following communication. In the early stages of the telecommunication age, these connections often consisted of circuit switch landlines. Today, point to point connections are achieved in modern telecommunication networks by a superordinate multiplex hierarchies or fiber optic networks. Depending on the type, P2Ps can be used to transmit analog or digital information. Bit transparency is a typical characteristic of a digital P2P. A point-to-point connection has to be installed by a provider and made available to the customer in order to be used for communication purposes. Point-to-point point-to-point link-based systems. A point-to-point link-based system provides dedicated links between two devices. For example, a wired system that connects two computers together can be truth of a point-to-point link. This is in contrast to a broadcast system where one system connects multiple other devices. A good example of a point-to-point system is a telephone call, where only two people are connected and communicating. Point-to-point protocol. What is a point-to-point protocol? The point-to-point protocol, or PPP or triple P, denotes a group of networking protocols which imply a standard method for transporting multi-protocol information over the point-to-point links. Point-to-point link-based systems. The point-to-point protocol denotes a group of networking protocols which imply a standard method for transporting multi-protocol information over the point-to-point links. There are three major components of point-to-point protocol. Number one, a multi-protocol datagram encapsulation method. Number two, a link control protocol for establishing, configuring, and testing the link connections. Number three, a collection of network control protocols for controlling network layer protocols. How does a point-to-point link work? A point-to-point link is a dedicated connection between two networking devices, such as two computers or a computer and a printer. The entire bandwidth of this link is used for data transmission between these two devices. Modern day point to point links are made up of PSTN, or public switch telephone networks, and modems. There are multiple connections between individual machines in a point to point network. The packet follows various routes to move from the source to destination. In the PPP, or point-to-point protocol, a data link protocol is helpful in providing a direct connection between two networking devices. PPP also provides encryption, authentication, and compression mechanisms. Multiple physical networks like a phone line, fiber optic, serial cable, trunk line, or radio links use PPP, and it can also be used over broadband activity. So here's the example of point-to-point link using PPP, or point-to-point protocol. This is called authentication and connection establishment. So what you see on the screen is Bob's personal computer, or your own personal computer, and a server. So you will create a username and your password, like Your username there is Bob123 and the password is Bob at 2014. And when you create a username or password or your account, it will go to the server. And the server will back to you as you will as the server will provide if the server will accept it or reject it. Yun. One. So next is branch connections. Branch networking defined. Branch networking refers to the elements used to distribute information to from and among remote sites, stores, branch offices, and data centers. Multi-site companies of all sizes, school systems, retailers, and other distributed organizations of all kinds are operating branch networks. But networking complexities and security concerns grow. Many branch networks are feeling mounting pressures. The complexity of branch networks. As a business grows, the need for new sites often requires a pace of deployment that traditional infrastructure doesn't fully support and incurs unwanted costs to meet minimum bandwidth needs. Traditional wide area network technologies such as MPLS quickly become outdated and expensive when managing a modern branch network. Bandwidth needs and costs are only increased by the adoption of cloud computing. With the accessibility of cloud and SaaS apps, rise of IoT devices, an increase in employee and consumer devices, a network's bandwidth can quickly be driven to capacity. So IoT devices is Internet of Time devices quickly be driven to capacity. The increasing popularity of video and voice technologies ensure this trend is not slowing down anytime soon. Branch networks with traditional wide area network technologies can be time consuming to provision and difficult to deploy. What is software defined branch networking or SD1? SDBN. Okay. So, software defined wide area networking or SD1 is an improved internet oriented approach to connecting network sites. SD1 technologies allow organizations to use mixtures of ISP connections per site intelligently and consolidate network operations into a single platform for greater efficiency. Many businesses look to SD1 as a way to augment or replace MPLS links with less expensive commodity broadband that can reduce costs and boost bandwidth. Branch office security and SD1. As a branch locations get connected directly to the internet with SD1, they become targets for internet-based attackers or hackers. First generation SD1 solutions often ignore security, leaving it to IT teams. I do not top IT teams like, networking companies, ID companies, and some sort. However, this fragmented approach left gaps at a time when cyber threats are growing in number and sophistication. Modern enterprises are realizing that connectivity and security must go hand in hand if sites are to safely access the information and resources they need. In addition, taking an integrated approach is crucial for providing visibility and consistent enforcement when data is stored across multiple SaaS apps, cloud platforms, and corporate systems. Centralized management and consolidation. Enterprise oriented SD1 solutions enable organizations to bring network operations and management into one console with a consistent view everywhere from data centers to remote sites and branch offices. IT can better understand exactly what is happening throughout the network to boost security and slash response times. And to this ability, add to this the ability to manage multiple type of connections, quickly provision bandwidth, and spin up new sites at a lower cost. And it's easy to see why more and more branch networks are turning to SD1. That's the end of it. So here we are at the last topic, the access control list. What is an access control list or ACL? An access control list or ACL contains rules that grant or deny access to certain digital environments. There are two types of ACLs, file system and networking. File system is the filter access to files and or directories. File system ACLs tell operating systems which users can access the system and what privileges the users are allowed. While the networking ACLs filter access to the network. Networking ACLs tell routers and switches which type of traffic can access the network and which the activity is allowed. What is the reasons to use an ACL? There are four reasons to use an ACL. One is traffic flow control, restricted network traffic for better network performance. Number three, a level of security for network access, specifying which areas of the server network services can be accessed by a user and which cannot. Fourth is granular monitoring of the traffic exiting and entering the system. So number one is traffic flow control. The the flow of the traffic within the internet and the server is the traffic flow control of internet and server, or the flow of the connection is the job. I know it's the job for the ACL to be smooth. Yun. So number two, restricted network traffic for better network performance. So the network traffic is being restricted or being secured for better network performance. For for to avoid slower network connections and slower internet connections. Yan. Number three, a level of security for network access, specifying which areas of the server network service can be accessed by user and which cannot. The level of security is high for network access, and it will specify which areas of the server network services can be accessed by the user, and those non-users is I and those non-users will not access the level of security for network access. Yeah. Granular monitoring of the traffic existing and entering the system. So ACL as a granular monitoring of the traffic, or the traffic flow of internet na that exiting and entering the system. Yun. How ACL works. A file system ACL is a table that informs a computer operating system of the access privileges a user has a system object, including a single file or a file directory. Each object has a security property that connects to its access control list. The list has an entry for every user with access rights to the system. When a user requests an object in an ACL based security model, the operating system studies the ACL for a relevant entry and sees whether the requested operation is permissible. Networking ACL are installed in routers or switches where they act as a traffic filters. Each networking ACL contains predefined rules that control which packets or routing updates are allowed or denied access to a network. There are two types. I don't know if it's two. Okay, okay. Two types of access control list: the standard and extended. The standard ACL is an access list that is developed solely using the source IP address. This access control list allow or block the entire protocol suite. They don't differentiate between IP traffic such as UDP, TCP, and HTTPS. They use numbers 1 to 99 or 1300 to 1999, so the router can recognize the address as the source IP address. Extended ACL, an access list that is widely used as it can differentiate IP traffic. It uses both source and destination IP addresses and port numbers to make sense of IP traffic. You can also specify which IP traffic should be allowed or denied. They use the numbers 100 to 199 and 2000 to 2619 or much higher. ACL best practices. ACLs everywhere. ACL in order. Document your work. ACLs everywhere. ACLs are enforced on each interface in nearly all security or routing gear. This is fitting as you can have the same rules for upward facing interfaces that form your campus network. However, interfaces are similar and you don't want some protected by ACLs and some exposed. ACL in order. In almost all cases, the engine enforcing the ACL begins at the top and moves down the list. This has implications of working out what an ACL will do with a specific data stream. Number three, document your work. When you add ACL rules, document why are you adding them, what they are intended to do, and when you added them. You don't need to have one comment per rule. You can make one comment for a block of rules, an intricate explanation for a single rule, or a combination of both approaches. Last, developers should ensure that the current rules are documented, so nobody needs to guess why a rule is there. So that's the end of those three topics that I reported, and thank you for listening, and that's it. Good night.